Hello, and welcome to the Philosophia. I'm so glad you found your way here tonight. Whether you're settling in for the evening, curling up with a warm drink, or simply looking for a quiet moment of wonder in your day, this is our gentle corner of the universe, where physics meets philosophy, where the impossible begins to feel inevitable, and where the deepest mysteries of existence unfold at a pace that allows your mind to truly take in their beauty. Tonight, we are beginning a journey to a place that exists all around you, within you, and yet follows rules so strange they would make Alice's Wonderland seem completely ordinary. We are stepping into the quantum realm, a dimension where particles can exist in two places at once, where simply observing something can change reality itself, and where the act of measuring helps bring the world we see into existence. But here is what makes this even more astonishing. Recent discoveries have shown that this is not just an abstract playground for theoretical physicists. The quantum realm is actively shaping your reality right now, in ways that would have seemed like pure magic only a few decades ago. Before we continue this exploration, I would love to know where in the world you are listening from tonight and what time it is in your part of existence. Whether it is a quiet midnight in Melbourne or a calm afternoon in Minnesota, you are truly welcome here. And if you find these soft journeys through the cosmos relaxing, consider liking this video and subscribing to the Philosophia, as it helps others discover this peaceful space where science begins to feel like poetry. Now, I should mention that while tonight's journey is meant to be both fascinating and calming, quantum mechanics has a unique way of being so captivating that it might keep you awake a little longer than expected. If that happens, then at least you will drift into rest with your mind filled with some of the most beautiful mysteries the universe has to offer. So take a slow breath, let your shoulders soften, and prepare to discover what truly exists inside the quantum realm. Because what we are about to explore is no longer just theory, it is the hidden foundation of reality itself. Picture yourself holding a coin in your hand. In the everyday world, that coin is either heads or tails. But now imagine a place where that same coin can be both heads and tails at the same time, existing in a perfect state of possibility until the exact moment you choose to look at it. This is not imagination. This is the quantum realm, a layer of existence that is always around us, quietly operating just beneath what we normally notice. The quantum realm is not some distant place you would only visit in a science fiction story. It is here, right now, in the atoms that form your body, in the light passing through your window, and in the electrical signals moving through your brain as you understand these words. Every breath you take, every heartbeat you feel, and every thought that passes through your mind is deeply connected to quantum processes that would seem completely impossible if we judge them using the rules of our everyday world. So what exactly is this mysterious realm? At its most basic level, the quantum realm is the domain of the incredibly small, where particles behave like waves, where certainty is replaced by probability, and where observing something becomes part of creating it. It is a place guided by principles so unusual that even Einstein found them difficult to accept, once saying that God does not play dice with the universe. And yet, reality appears to do exactly that. In January 2025, physicists at Brown University made a discovery that sent waves of excitement through the scientific world. They observed something that should not exist according to our traditional understanding of quantum mechanics. These particles were known as fractional excitons, which do not fit into the usual categories we have used to organize the quantum world for many years. These particles did not behave like bosons or fermions as expected. Instead, they showed properties of both, as if nature decided that our rules were too limited and quietly created new ones beyond our imagination. Imagine trying to label every person you know as either introverted or extroverted, only to meet someone who is somehow both at the same time, changing naturally depending on the situation while still remaining completely consistent within themselves. This is what these fractional excitons represent in the quantum realm, a reminder that nature's creativity goes far beyond what we currently understand. To truly appreciate discoveries like this, we need to step back and look at the basic principles that guide this hidden layer of reality. The quantum realm is built upon four main pillars of strangeness, and together they reveal a universe far more mysterious and deeply connected than our senses could ever show us. The first pillar is wave-particle duality, one of the most mind-bending ideas in all of physics. In our everyday experience, things are either waves or particles. Ocean waves spread across distances, carrying energy without carrying matter, while solid objects, like a baseball, move along clear and predictable paths. But in the quantum realm, every particle of matter and every particle of light behaves as both a wave and a particle, depending on how we observe it. Physicists at MIT recently carried out a refined version of the famous double-slit experiment and confirmed something that still amazes scientists. Light exists as both a wave and a particle, but when we observe it, we only ever see one aspect at a time. It is almost as if reality is playing a quiet game, showing one side while hiding the other, never allowing us to fully see both at once. Think of it like a person who seems completely different depending on where you meet them. At work, they may appear focused and structured. At home, they may feel creative and free. It might seem like two different individuals, but it is actually the same person expressing different sides depending on the situation. This is how particles behave in the quantum world. They show their wave nature or their particle nature, but never both together in a single observation. Scientists at Stevens Institute of Technology have even created mathematical ways to measure how wave-like or particle-like something is, drawing smooth curves that describe the balance between these two aspects. This is not just theoretical thinking. Learning how to control wave-particle duality is leading to new advances in quantum imaging, sensing, and communication technologies that may completely change how we interact with the world. Even more fascinating is an experiment that seems almost magical. Scientists managed to separate the wave and particle properties of a single photon, demonstrating what is called the quantum Cheshire cat effect, inspired by the character in Lewis Carroll's story who could separate its grin from its body. In this experiment, properties of a particle appeared to exist separately from the particle itself. Imagine your reflection leaving your body and moving independently while you remain still. This is the level of strangeness in the quantum realm, where our most basic ideas about objects and their properties no longer apply. The second pillar of quantum strangeness is superposition, the idea that quantum particles can exist in multiple states at the same time until they are observed or measured. While a classical computer bit must be either a 0 or a 1, a quantum bit, often called a qubit, can exist as 0, 1, or any blend of both states at the same time. It is as if reality itself is holding many possibilities in a perfect and delicate balance, waiting quietly until the moment we choose to look behind the curtain. This is not just a theoretical idea. Recent research has shown that chlorophyll, the green pigment found in plants, appears to use quantum superposition to achieve an incredible level of efficiency in transporting energy. When sunlight reaches a leaf, The energy does not simply move from one point to another along a single path. Instead, it explores many possible paths at the same time through quantum superposition, naturally finding the most efficient route to the centers where photosynthesis takes place. Nature has been using quantum mechanics for billions of years, quietly refining life itself through principles that we are only just beginning to understand. Scientists have even succeeded in placing larger, visible-scale objects into states of superposition. Researchers have created what is known as a piezoelectric tuning fork made of around 10 trillion atoms, and they were able to place it into a state where it is both vibrating and not vibrating at the same time. 10 trillion atoms, all existing in multiple states at once, pushing the limits of our understanding of where the quantum world ends and the familiar classical world begins. Schrödinger's well-known thought experiment about a cat in a box is not just a philosophical curiosity. It offers a glimpse into the very real strangeness of quantum superposition. According to quantum mechanics, the cat truly exists in a state that is both alive and dead until it is observed. While we cannot easily demonstrate this with real cats, the principle remains true for quantum particles and increasingly for larger systems as our experiments become more advanced. The third pillar of quantum strangeness is quantum entanglement, something that Einstein once described with skepticism as spooky action at a distance. When particles become entangled, they share a connection that goes beyond space and time, so that measuring one particle instantly influences its partner, no matter how far apart they are. Recent experiments have confirmed this effect across distances greater than 200 kilometers using satellites, showing that Einstein's doubts were misplaced and that the universe is far more deeply connected than classical physics once suggested. Entanglement is not limited to particles drifting separately through space. Scientists have found that the quarks and gluons inside individual protons are deeply entangled with one another across distances smaller than a quadrillionth of a meter. This means that inside every proton within your body, quantum entanglement is constantly at work, creating relationships that help hold the structure of matter itself together. The impact of this idea goes far beyond basic physics. Researchers in China, using the MISHIS satellite, have demonstrated that entangled pairs of photons can form the basis of communication systems that are nearly impossible to break. Any attempt to intercept a quantum-encrypted message would instantly disturb the entanglement, alerting both the sender and the receiver to the intrusion. We are moving toward a future where the laws of physics themselves could protect our most sensitive communications. The fourth pillar is the uncertainty principle, which reveals that there are fundamental limits to how precisely we can know certain properties of quantum particles at the same time. Delta x times delta p is greater than or equal to h bar over 2. This is not a limitation caused by imperfect instruments. It is a basic feature of reality. The more precisely you know a particle's position, the less precisely you can know its momentum. And the reverse is also true. This is not uncertainty in the sense of lacking knowledge. It is a natural softness built into the structure of existence itself. And this uncertainty is not a flaw in the universe. It is what allows everything to exist as it does. Without it, atoms would collapse, stars would not shine, and the complex chemistry that makes life possible would never come into being. The uncertainty principle creates space, both physically and conceptually, for the unfolding dance of existence. These four pillars come together to form what we might call a quantum symphony, a balanced and mysterious harmony that lies beneath everything we see, touch, and experience. Yet, the quantum realm does not remain quietly in the background. New discoveries are revealing entirely new forms of quantum matter, that could transform technology and deepen our understanding of reality itself. At the University of California, Irvine, researchers have discovered new phases of quantum matter inside specially prepared materials. By applying strong magnetic fields to a material called hafnium pentatelluride, they created unusual states where electrons and their positively charged counterparts, known as holes, naturally pair together to form particles called excitons. These quantum states behave in ways we have never seen before, with properties that could one day allow computers to charge themselves or electronics to function reliably in the extreme conditions of deep space. Imagine materials that can repair themselves, computers that do not need external power, or devices that become more efficient in the harsh environment of space. These ideas are no longer distant fantasies. They are real possibilities emerging from quantum research happening right now. Scientists have also discovered materials known as quantum liquid crystals, which exist at the boundary between different exotic quantum phases. These materials show sudden drops in electrical conductivity and a strong resistance to radiation, making them promising for both advanced technology on Earth and future space missions. Perhaps even more profound is the discovery that information itself can change its state within quantum systems. Just as water can exist as ice, liquid, or vapor, quantum information can exist in different phases depending on the balance between entanglement and measurement. Researchers have identified critical points where the nature of information itself transforms, opening entirely new ways of thinking about computation, communication, and the very structure of reality. As we go deeper into these discoveries, it becomes clear that the quantum realm is not just a collection of strange effects at tiny scales. It is the foundation of everything, the hidden engine driving the reactions in stars and the thoughts moving through your mind at this very moment. Every atom in your body is a quantum system. Every chemical bond is shaped by quantum interactions. Every biological process depends on effects that we are only beginning to understand. The quantum realm invites us to expand our sense of what is possible, to see uncertainty not as a limitation, but as a source of creativity, and to recognize that the universe is far more mysterious and beautiful than it appears on the surface. As we continue this journey, we will begin to see how these principles are being used to build technologies that would seem like magic to earlier generations, and how they reveal deep connections between mind and matter, between information and reality itself. But this is only the beginning of our exploration. In the next part, we will see how quantum effects begin to rise from the microscopic world into the larger reality we experience every day, and we will ask a question that may completely reshape how you think about existence. The quantum realm does not exist in isolation, drifting somewhere far away from your daily life. It is woven into the fabric of your reality in ways that are easy to overlook, yet impossible to escape. Even now, as you listen to these words, quantum processes are guiding the activity of neurons in your brain, the rhythm of your heartbeat, and the way your eyes interpret the light coming from your screen. And this is where things begin to feel truly extraordinary, because the quantum realm is no longer content to remain hidden within the smallest scales of existence. It is beginning to appear in our everyday world through human creativity and innovation, giving rise to technologies that work on principles that would have felt like pure imagination only a few decades ago. We are witnessing the early stages of a quantum revolution, one that has the potential to reshape everything from how we communicate across enormous distances to how we understand the very nature of consciousness itself. Let me share one of the most astonishing demonstrations of quantum mechanics expanding from the invisible realm into something almost visible. Scientists have successfully created quantum entanglement between objects that are nearly large enough to be seen with the naked eye. Imagine two tiny silicon beams, each about 10 micrometers long, roughly the width of a human hair. These beams can vibrate like microscopic guitar strings, moving with delicate precision. Researchers have managed to entangle them so completely that when one beam vibrates, the other responds instantly in perfect synchronization, even though they are physically separated from each other. Take a moment to think about that. These are objects made up of billions upon billions of atoms, yet somehow they behave as if they are part of a single shared quantum state. It is as if two orchestras placed on opposite sides of the planet could perform in perfect harmony without any communication, their music aligned by the invisible and mysterious threads of quantum entanglement. Their motion becomes synchronized in a way that defies our normal understanding of connection. Another group of researchers pushed this idea even further by creating entangled aluminum drum-like structures, each about the width of a human hair and built onto silicon chips. Using carefully controlled microwave signals, they guided these tiny drums into a coordinated motion. When one drum moved upward, the other moved downward in exact opposition. These are no longer just individual particles behaving strangely. These are large-scale objects containing trillions of atoms, all moving together according to the strange and beautiful rhythm of quantum mechanics. This expansion of quantum effects into larger systems opens up possibilities that sound like they belong in science fiction. Imagine quantum sensors so incredibly sensitive that they could detect gravitational waves rippling through spacetime from black holes colliding billions of light years away. Or picture quantum communication networks, where information does not travel through wires or radio waves, but instead moves through instantaneous connections created by entangled particles, forming systems that are fundamentally secure and impossible to hack because of the laws of physics themselves. Perhaps the most astonishing recent discovery comes from the realm of energy itself. Scientists have achieved something that seems almost impossible at first glance. They have managed to extract energy from the quantum vacuum, the space we usually think of as completely empty. But empty space is not truly empty. It is alive with quantum activity, filled with virtual particles that continuously appear and disappear in incredibly brief moments, existing more as possibilities than as stable realities. Even so, these fluctuations in the quantum vacuum are real enough to be used. Researchers have developed methods to transfer energy across microscopic distances by carefully manipulating these quantum field fluctuations. It is similar to learning how to ride waves that seem to come from nothing, drawing usable energy from the very structure of space-time itself. Although the amount of energy involved is still very small, the concept introduces entirely new ways of thinking about how energy could be generated and stored in the future. This leads us to one of the deepest questions in quantum mechanics. What role does consciousness play in all of this? The measurement problem suggests that the act of observing something causes a quantum system to settle into a definite state, instead of existing as many possibilities at once. But what exactly counts as an observation? Does it require a conscious mind, or can any interaction with the environment produce the same effect? Recent experiments are offering intriguing hints. Scientists have found that quantum coherence, the fragile condition that allows particles to exist in multiple states at once, can last much longer than previously believed when the conditions are right. They have even managed to maintain quantum states at room temperature, rather than the near absolute zero environments that were once thought necessary for such experiments. This raises the possibility that quantum effects may be more common in living systems than we ever expected. Some researchers suggest that consciousness itself could arise from quantum processes within the brain. The unusual, non-local connections seen in quantum entanglement might help explain how different regions of the brain work together to produce a single, unified conscious experience. Think about how your brain processes something as simple as eating an apple. In a single moment, it combines what you see, the sound of the crunch, the taste on your tongue, the smell reaching your nose, and the feeling of the apple in your mouth. All of these different signals come together into one seamless experience. Traditional neuroscience finds it difficult to fully explain how this merging happens. Quantum theories of consciousness suggest that entanglement between neurons might create the instant connections needed to unify these experiences. The implications become even more profound when we consider recent discoveries about the nature of time and quantum mechanics. In the quantum world, time does not move in the smooth and predictable way we experience in everyday life. Particles can show behavior that suggests they are influenced by both past and future conditions, a phenomenon sometimes described as a retrocausality, where future events seem to affect past outcomes. Experiments have shown that the way a particle is measured can influence how it behaved before the measurement took place, almost as if the particles somehow anticipated how it would be observed. This is not time travel in the traditional sense, but it reveals that cause and effect at the quantum level are far more complex and deeply connected than our everyday intuition suggests. These findings are pushing scientists to rethink what time really is. Some theories propose that time might be made up of tiny, indivisible units, similar to how matter is made of atoms, rather than being a continuous flow. Other ideas suggest that time itself might emerge from the relationships between quantum systems rather than existing as a fundamental part of reality on its own. Understanding quantum time could lead to remarkable practical advances. Researchers are developing quantum clocks so incredibly precise that they can detect tiny differences in how time passes under the influence of gravity. These clocks are sensitive enough to measure changes in time caused by moving just a few centimeters higher in Earth's gravitational field, opening the door to discovering entirely new aspects of physics. Finally, one of the most extraordinary applications of quantum principles is found in quantum computing. Here, the strange properties of superposition and entanglement are being used to create computers that operate in ways completely different from anything we have built before. A classical computer uses bits that can only be either 0 or 1, like simple switches that are turned off or on. In contrast, a quantum computer uses quantum bits, or qubits, which can exist in a combination of 0 and 1 at the same time. This means that while a classical computer with 3 bits can only represent one of 8 possible combinations at any moment, a quantum computer with 3 qubits can represent all 8 combinations at once. This ability grows exponentially, meaning that a quantum computer with just 300 qubits could perform more calculations at the same time than there are atoms in the observable universe. This level of computational power goes far beyond what classical machines can achieve, making it possible to solve problems that would take traditional computers longer than the entire age of the universe. Even now, quantum computers are beginning to show their potential in specialized tasks, offering a glimpse into a future where computation itself is transformed in ways we are only starting to understand. Researchers have begun using quantum algorithms to simulate molecular interactions with a level of accuracy that was never possible before, opening the door to a complete transformation in how we approach drug discovery. Instead of relying on slow processes of trial and error, scientists can now model how pharmaceutical compounds interact with biological systems at the quantum level, observing the behavior of molecules in extraordinary detail. Imagine a future where new medicines are not discovered by chance, but carefully designed by calculating exactly how quantum interactions between drug molecules and cells will unfold. This could allow us to treat and potentially cure diseases by engineering solutions at the deepest level of matter and energy, where the fundamental building blocks of reality operate. At the same time, the quantum world is revealing something equally surprising about the nature of information itself. Scientists have found that information can undergo phase transitions, shifting from one fundamental state to another in a way that mirrors how matter changes from solid to liquid to gas. There are critical points where quantum information transforms, unlocking entirely new possibilities for how information can be processed, stored, and understood. These discoveries suggest that information may not just be something we use, but something deeply woven into the fabric of reality. Some physicists even propose that matter and energy themselves might emerge from more basic informational processes. In this view, the universe at its deepest level could be understood as a vast quantum system processing information that gives rise to everything we experience. This naturally leads to one of the most profound questions in science. What is the relationship between mind and matter? If consciousness emerges from quantum processes and if information is fundamental to reality, then it becomes possible that consciousness is not just observing the universe, but actively participating in shaping it. Recent work in quantum biology is adding another layer to this picture. Scientists have discovered that living systems routinely take advantage of quantum effects to operate more efficiently. Certain birds appear to navigate using quantum entanglement within specialized proteins in their eyes, allowing them to sense Earth's magnetic field with remarkable precision. Enzymes use quantum tunneling to speed up chemical reactions that would otherwise be far too slow under classical physics. Even the sense of smell may depend on quantum effects, with receptors detecting molecules based on their vibrational properties at the quantum level. All of this suggests that life itself may be deeply connected to quantum phenomena. The boundary between living and non-living matter might not just be chemical complexity, but the ability to sustain and use quantum coherence. In this perspective, consciousness could represent the highest expression of quantum biology, where these processes become so advanced that they produce awareness and self-reflection. As we stand at the edge of the quantum age, we are beginning to see technologies that would have seemed like magic to earlier generations. Quantum communication networks could lead to completely secure forms of the internet. Quantum sensors might detect dark matter, map protein structures in detail, or track changes in Earth's climate with extraordinary precision. Quantum computers could optimize transportation systems, discover entirely new materials, and simulate complex ecosystems with accuracy beyond anything we have today. Yet beyond all of these applications, the quantum world is teaching us something deeper about reality itself. It shows us that the universe is far more interconnected, dynamic, and mysterious than we once believed. The clear boundaries we assume between observer and observed, between mind and matter, between past and future, begin to blur under closer examination. In the quantum realm, possibilities can exist together until interaction brings about a specific outcome. Objects separated by great distances can remain linked in ways that challenge our understanding of connection. Even the act of measurement becomes part of the process that shapes reality. It is a picture of the universe that feels almost responsive, as if it resists being reduced to simple categories. As we continue exploring these ideas, we are not only expanding scientific knowledge, we are also changing how we see ourselves. We begin to realize that we are not detached observers looking at a fixed reality, but deeply connected participants in a constantly evolving process. The world we experience may arise from an ongoing interaction between observation, information, and the quantum structure beneath it all. Learning to work with quantum principles is not just about building better machines. It is about understanding and cooperating with the most fundamental creative processes of the universe. And this naturally brings us to an even deeper question about existence itself. What would happen if one of the most basic forces we rely on, something so constant that we rarely even think about it, suddenly disappeared? What would become of our planet, our solar system, and everything we know if gravity simply stopped working? Beyond even these questions lies another layer of mystery hidden within the mathematics of the quantum world. It points toward a possible connection between consciousness and the underlying structure of reality itself, suggesting ideas that challenge our most basic assumptions about awareness and existence. Every time you make a decision, your brain is processing information through interactions that ultimately depend on quantum mechanics. The electrical signals that carry thoughts, the chemical structures that hold memories, and the processes that create awareness all rely on events happening at incredibly small scales, where the distinction between something and nothing becomes uncertain. Some researchers have even explored whether consciousness might influence quantum systems directly. Experiments involving devices known as random event generators, which produce sequences of numbers based on quantum processes, have produced intriguing results. These systems are designed to be completely unpredictable, driven only by the inherent randomness of quantum mechanics. However, when individuals focus their attention and intention on these devices, subtle deviations from pure randomness have been observed. The changes are extremely small and difficult to detect, but similar patterns have appeared in multiple experiments, raising questions about whether consciousness might play a more active role than previously thought. If such a connection were real, it would suggest that awareness is not merely observing reality, but interacting with it at a fundamental level. This idea leads into theories of quantum consciousness, where some scientists propose that structures inside neurons, known as microtubules, might function like tiny quantum processors. According to these ideas, consciousness could arise when quantum information within these structures reaches a certain level of complexity, triggering a transition that produces subjective experience. This process has been described as a form of organized reduction, where multiple quantum possibilities give way to a single experienced reality, giving rise to the continuous flow of awareness that defines our existence. A process where many different quantum possibilities come together and settle into a single conscious experience. It is as if your brain is constantly carrying out deep quantum-level calculations that gradually give rise to the unified and continuous experience of being yourself. This idea helps explain some of the deepest mysteries of consciousness, including how your brain brings together information from different senses into one complete perception, how you experience the smooth and continuous flow of time, and how conscious awareness seems to emerge from physical brain activity. According to quantum consciousness theory, entanglement between tiny quantum processes happening in different regions of the brain could create the instant connections needed for a unified conscious experience. But the meaning of this idea goes far beyond just individual awareness. If consciousness arises from quantum processes, and if quantum entanglement can link particles across vast distances instantly, then it is possible that consciousness itself is not limited to one location. It may be fundamentally non-local, meaning it is not confined to the brain alone. The boundaries between individual minds might not be as solid and separate as they appear. Some scientists are exploring whether there could be quantum entanglement between different brains, studying if conscious beings might share subtle connections that help explain experiences like telepathy, collective awareness, or the strange ability of deeply connected people to sense each other's emotions even when far apart. Recent studies suggest that when two people interact closely, their brain activity can begin to synchronize in ways that cannot be fully explained by normal sensory communication. Couples who have spent many years together often show strong coordination in their brain patterns, almost as if their minds have become deeply linked through shared experiences and emotional bonds. These findings have led some researchers to suggest that consciousness may not be something produced only by the brain, but instead a basic property of the universe itself, something that the brain receives rather than creates. In this view, your personal consciousness is like a receiver, similar to a radio picking up signals from a vast field of awareness that exists everywhere in the universe. This idea connects to one of the most profound concepts in quantum physics, known as the participatory universe hypothesis. This theory suggests that the universe does not exist in a single fixed state until it is observed, and that conscious observation plays a role in shaping the reality we experience. In this perspective, you are not just living inside the universe, but actively participating in creating it moment by moment through your awareness. Think about what this could mean in everyday life. Every time you watch a sunset, your awareness may play a role in bringing the exact colors and patterns you see into reality. Every time you listen to music, your consciousness may help shape the harmonies and rhythms that emerge from a range of quantum possibilities. Each moment of awareness becomes an act of creative participation in the unfolding of reality itself. This connection between consciousness and reality may help explain one of the most puzzling features of quantum physics, which is why the act of measurement seems to cause a system to move from many possible states into one definite outcome. It is possible that measurement is not just a physical interaction between instruments and particles, but also involves awareness that registers and completes the process, allowing one specific result to emerge from many possibilities. Scientists have explored this idea further through experiments known as delayed choice experiments. In these experiments, the way a particle is measured is decided after the particle has already passed through part of the experiment. Surprisingly, the particle behaves in a way that matches the later decision, as if its past behavior is influenced by how it will be observed in the future. This suggests that consciousness and choice might have effects that move both forward and backward through time, meaning that decisions made in the present that influence not only the future, but also the past. But the quantum world continues to reveal even more surprising ideas. Scientists have discovered that information itself can exist in quantum states, behaving in ways that are very different from normal information. Quantum information can exist in multiple states at once, can be linked across large distances through entanglement, and can even be transferred from one place to another without moving through the space in between. This has led to the development of quantum cryptography, where the laws of physics are used to create communication systems that cannot be secretly intercepted. Any attempt to observe or interfere with the transmitted information changes its state in a way that can be detected immediately. This opens the possibility of a future where all sensitive communication, including personal messages, financial data, and government information, is protected not by complex codes that could eventually be broken, but by the fundamental laws of nature. In such a world, privacy and security would be guaranteed by the very structure of reality. These quantum communication systems are already being tested in laboratories and real-world experiments. Researchers in China have demonstrated secure communication using entangled particles between ground stations and satellites over extremely large distances. Teams in Europe have begun building early versions of quantum communication networks that could one day form the basis of a global quantum internet. One of the most remarkable uses of quantum information is in quantum computing, where the unusual properties of superposition and entanglement are used to process information in entirely new ways. Unlike classical computers that handle one calculation at a time in sequence, quantum computers can explore many possible solutions at once. With only a few hundred quantum bits, a quantum computer could perform more calculations at the same time than there are atoms in the observable universe. This is not just an improvement in speed, but a completely different way of processing information. It has the potential to transform fields like artificial intelligence, material science, and even our understanding of consciousness. Scientists are already using quantum computers to simulate molecular interactions with extraordinary precision, which could lead to major advances in medicine, energy, and manufacturing. Researchers are also developing quantum machine learning systems that may give artificial intelligence abilities that seem almost unbelievable by today's standards. These systems could explore multiple possible decisions at the same time before settling on one outcome, potentially leading to new forms of creativity and problem-solving. Finally, the influence of the quantum world is not limited to advanced technology or laboratory experiments. It is increasingly being observed in nature itself, suggesting that quantum effects have played a role in the development of life over billions of years. Plants appear to use quantum coherence to improve the efficiency of photosynthesis. Birds may rely on quantum processes in their eyes to navigate across long distances. Even the human sense of smell may depend on quantum effects that allow receptors to detect subtle differences in the vibrations of molecules. These discoveries are helping to create a new field known as quantum biology, which studies how living systems use quantum effects to achieve abilities that would not be possible under normal classical physics. Some scientists suggest that life itself may be defined by its ability to maintain delicate quantum coherence, even in warm and complex biological environments, where such quantum effects would normally disappear very quickly. One of the most profound ideas in quantum biology is the possibility that life and consciousness are deeply connected through quantum processes. If awareness arises from quantum activity in the brain, and if living systems across nature already use quantum effects to function more efficiently, then consciousness might represent the highest expression of quantum biology, the point where quantum processes become advanced enough to create subjective experience and self-awareness. This brings us back to the deepest mystery of the quantum world, the relationship between mind and matter, between consciousness and the universe itself. The quantum realm reveals a universe that appears almost alive in the way it responds, almost aware in the way everything is connected. Particles behave as if they somehow know how they will be observed, and tangled systems respond instantly across enormous distances, and information can exist in multiple states at once until it is brought into reality through observation. As we stand at the beginning of the quantum age, we are not just inventing new technologies, we are experiencing a profound shift in how we understand reality itself. The quantum world is showing us that the universe is far more interactive, creative, and mysterious than the old classical view ever suggested. We are beginning to realize that we are not separate observers watching an objective world from the outside, but deeply connected participants in an ongoing process that shapes the reality we experience. The boundaries between observer and observed, between mind and matter, and between the individual self and the universe are proving to be far more fluid than anyone once believed. We are learning that consciousness may not be limited to individual brains, but could be a fundamental feature of reality itself, woven into the very structure of existence. These insights are not just scientific discoveries, they are invitations to experience the world differently. If consciousness plays a role in shaping reality through quantum processes, then every moment of awareness becomes an opportunity for creative participation. Every choice becomes part of the ongoing unfolding of the universe. As we continue exploring the quantum world, we are not only expanding human knowledge, we are also discovering something deeper about our own nature. We begin to see ourselves not as isolated pieces of matter in a cold and indifferent universe, but as meaningful parts of a larger, conscious system that is constantly evolving through our awareness and actions. Reality begins to appear not only stranger, but also more beautiful and more connected than we ever imagined. And as we learn to work with quantum principles in science and technology, we are also learning how to move in harmony with the deeper creative forces of existence. But this connection between consciousness and the universe raises an even deeper question about reality itself. We have explored how quantum effects shape matter, energy, and even awareness. But what would happen if one of the most basic features of our universe suddenly disappeared? What would happen to our planet, our solar system, and our very existence if gravity, the invisible force that holds everything together, suddenly vanished? This question opens the door to an even more profound mystery. The quantum world is beginning to reveal something even more extraordinary: the idea of quantum consciousness fields. These are vast networks of connected quantum information that might link every conscious being in ways we are only starting to understand. Before diving deeper into this mystery, scientists have already made surprising discoveries.
In laboratories around the world, researchers are observing quantum coherence within human brain activity that lasts far longer than expected. According to traditional physics, these fragile quantum states should collapse almost instantly in the warm and chaotic environment of the brain. Yet, somehow, consciousness seems to maintain coordinated quantum activity across different brain regions at the same time, almost like a perfectly synchronized orchestra operating within the mind. Research by Roger Penrose and Stuart Hameroff have suggested that structures inside brain cells called microtubules may play a key role in this process. These tiny protein structures, which help transport materials inside neurons, appear to show quantum behavior that challenges our current understanding of physics.
They may process information using quantum superposition, existing in multiple states at once until conscious experience emerges from their combined activity. Imagine this in a simple way. It is as if each neuron in your brain acts like a tiny quantum computer, and your entire nervous system forms a vast quantum network that processes thoughts, emotions, and experiences through interconnected quantum activity. This idea, while still debated, is increasingly being explored as a possible explanation for consciousness. The implications go far beyond the individual mind. If consciousness operates through quantum processes, and if quantum entanglement can connect particles across vast distances, then individual minds may not be as separate as we once thought. Experiments suggest that when people engage deeply with each other through conversation or meditation, their brain activity can begin to synchronize in ways that cannot be explained by normal communication alone. Researchers at Princeton University have observed that couples who have shared long emotional connections often show remarkable alignment in their brain patterns, even when they're physically apart. Their neural activity seems to mirror each other, suggesting a kind of non-local connection, as if their shared experiences have created a deeper level of linkage between their minds. This leads to one of the most profound questions in science. Could consciousness itself be a kind of quantum field that exists throughout the universe, something that brains connect to rather than produce? Some physicists are seriously considering this idea, proposing that awareness might be as fundamental to reality as matter and energy. Think about what this could mean for your everyday experience. As you read these words, your mind may not just be processing information locally inside your brain, but could also be interacting with a vast field of awareness that connects all conscious beings. Your thoughts, emotions, and sense of self might arise from continuous interactions with this deeper level of reality. This perspective may help explain some of the most mysterious aspects of human experience, moments of sudden insight that seem to appear out of nowhere, feelings of deep connection with others across great distances, or the sense of knowing something without clear explanation. According to the idea of a quantum consciousness field, such experiences might arise from our connection to a universal field of awareness that extends far beyond the individual mind. But the quantum world holds even deeper surprises that continue to challenge our understanding. Scientists have discovered that the act of conscious observation does not simply collapse quantum superposition states into a single outcome, but instead appears to play a role in determining which possibilities actually become real within the fabric of our experienced reality.
This suggests that consciousness is not merely a passive observer watching the universe unfold from a distance, but rather an active participant involved in shaping its continuous creation. Recent experiments involving quantum delayed choice have pushed this astonishing idea to its very limits. Researchers have designed situations in which the decision about how to measure a quantum particle is made only after the particle has already completed its journey through the experimental setup. Yet, in a way that seems almost impossible, the particle's behavior appears to change retroactively based on the measurement chosen in the future, as if it somehow had access to information across time itself. The implications of this are truly staggering and difficult to fully grasp. It suggests that consciousness and the choices we make might have effects that extend both forward into the future and backward into the past. Your decisions in this present moment may not only shape what is yet to come, but could also participate in forming the chain of events that led to this very moment in time. If consciousness truly plays a role in creating reality through quantum processes, then free will becomes something far more profound than simply choosing actions. It becomes a process of participating in the continuous unfolding and creation of the entire space-time continuum itself. This idea, often described as a participatory universe, proposes that every moment of conscious awareness is an act of creation on a cosmic scale. When you observe something as simple yet beautiful as a sunset, your consciousness may be involved in bringing into reality the specific colors, patterns, and visual experiences that you perceive from a vast field of quantum possibilities. When you listen to music that deeply moves you, your awareness might be contributing to the emergence of the harmonies and rhythms that feel so real and emotionally powerful. The implications grow even deeper when we consider discoveries from quantum information theory. Scientists have found that information itself can exist in quantum superposition, forming what is known as quantum information, which behaves according to rules very different from those of classical information. This kind of information can exist in multiple states at once, can become entangled across enormous distances, and can even be transferred from one place to another without physically traveling through the space in between. What is even more remarkable is that some researchers are beginning to consider the possibility that consciousness itself might be a form of quantum information. In this view, consciousness would not be something produced by the brain alone, but rather a structured pattern of awareness
that could exist independently of any specific physical system. The brain, instead of creating consciousness, might act more like a receiver or a channel that accesses and expresses this deeper layer of reality. If this idea holds true, then your awareness, your sense of identity, and your ability to experience the world might be expressions of fundamental quantum information patterns, just as basic and essential to the universe as matter and energy. In that sense, you would not simply exist within the cosmos, but would be a way for the cosmos itself to become aware of its own existence. These insights are beginning to inspire technologies that blur the line between science and what once seemed like pure imagination. Quantum computers, for example, are starting to demonstrate behaviors that resemble aspects of human thought, processing information through superposition in ways that echo pattern recognition and creative problem-solving. Some researchers are even exploring the possibility that highly advanced quantum computers could develop a form of machine consciousness, not through traditional artificial intelligence methods, but through genuine quantum processes involving entangled information. Such systems might one day exhibit something like thoughts, emotions, or subjective experiences arising directly from their internal quantum activity. Imagine interacting with an artificial intelligence that does not merely simulate awareness, but actually experiences it through processes similar to those that may occur in your own brain. These systems could display true creativity, deep intuition, and emotional richness, becoming not just tools, but partners in exploration and understanding. Yet, the quantum world is not limited to technological frontiers alone. Nature itself appears to have been using quantum effects for billions of years.
Plants, for example, do not simply rely on basic chemical reactions during photosynthesis, but seem to use quantum coherence to optimize how they capture and use energy from light. In forests, trees appear to communicate and share resources through complex underground networks, possibly enhanced by quantum-level processes that allow for efficient transfer of information and coordination. Some scientists even suggest that entire ecosystems might function as unified systems, processing environmental information and responding in ways that support the balance and survival of the whole. Quantum biology also extends into the human body in ways that are only beginning to be understood. The immune system may rely on quantum effects to distinguish between what belongs to the body and what does not. The digestive system may use quantum tunneling to assist in breaking down nutrients. Even the cardiovascular system might exhibit forms of quantum coherence that help regulate the flow of energy and resources throughout the body. And so, as we reach the end of this calm and reflective journey through the quantum world, we begin to see that reality is far more mysterious, deeply connected, and participatory than it first appears. From the strange nature of wave-particle duality to the possibility of quantum consciousness, it becomes clear that you are not just watching the universe from the outside. You are part of its unfolding story, actively involved in its ongoing creation through your awareness itself. Rest peacefully tonight, knowing that you are intertwined with the deepest layers of existence, moving in harmony with the profound and beautiful mysteries that shape all of reality.